Solving linear equations by the method of elimination. Okay, so we have two linear equations. We know they're linear because our x values kind of to the power of 1. There's nothing there. So we'll call this equation 1 and equation 2. Now, to solve by elimination, what we do, and they've already done this for us, so actually, you know what I'll do? I'll reverse it. Oh, I can't. Sorry. What we need to do is we need to line up our variables. We need to have our x's above our x's and our y's above our y's, and whatever's on the other side of the equal sign, so usually our constants with each other. Okay. Now they've already done this for us. Very kind of them. So what we're going to do is we need to eliminate a variable. Okay. So with elimination, we have the choice of either adding the two equations together, or we can subtract them. Okay. It's completely up to us, but we have to figure out how to eliminate one of the variables. Now, in order for the variables to be eliminated, the coefficients, do you know what the coefficients are?
The letters, right?
The letters are the variables.
Okay, so then the letters beside the numbers beside the letters.
That's exactly right. The numbers beside the letters are called coefficients. The coefficients have to have the same value. Okay. So let's look. Do our x coefficients have the same value? No. So we might have to change some stuff in this equation. Now, do our y coefficients have the same value? What number is in front of these y's? Nothing. Well, what do we assume is there?
A 1.
Yeah. So are the values technically, the absolute values the same?
Not really.
Why not?
Positive and negative.
Okay, so one's positive and negative, and that is actually going to work for us. Okay, just as long as the value of the number is the same. That's what we're looking for. So luckily, the value of the y's, the coefficient value, 1 is the same. So this works out great. 1 is positive, 1 is negative. What operation would I use to get positive 1 and negative 1 to equal 0? So let's think about it. We have two options, okay? We have positive 1 plus negative 1, or we have positive 1 minus negative 1. Okay? Let's put these in a calculator and figure out what each of them equals.
Okay.
0?
Yeah.
Okay, so that one is probably going to work. Okay. Positive 1 plus negative 1 is 0. Let's just test the other one. Positive 1 subtract negative 1. 2. Okay, not going to work for us. We need them to eliminate, hence the elimination title. Okay, so we need these to eliminate. So what we're going to do is we're going to add. So we're going to add these two equations together. That way, when we add these values, they eliminate. So positive 1y plus negative 1y will actually give us
0.
Yeah, we'll say 0y. And really that eliminates it. It's gone.
Yeah.
Now with the other columns, we do have to add. What is 3x plus 2x going to be?
5x.
That's right. And what is 7 plus 3 going to be?
10.
10. Okay, so the y's have disappeared. So now what we read is just 5x equals 10. How can we solve for x here? How do we bring that 5 to the other side?
It becomes a negative.
Not a negative because this is 5 times x. So what's the opposite operation?
Division.
Division. So what is 10 divided by 5 going to be?
4.
Try it in the calculator. Okay. 2, that's right. So our x value is 2. Great. Now what we're going to do is, this is the harder part. We're going to rewrite them. So we've eliminated to solve for x, but we still need to find a y value. Okay. So let's rewrite our two equations again. Equation 1 was, what happened there? Okay. 3x plus, and I'm going to write the 1 in, okay? 1y equals 7. Now this becomes the harder part. 2x minus 1y equals 3. Okay, the reason this becomes a little more difficult is now with our x's, are our coefficients the same value here? So are those coefficients the same value there? No.
Except for y is.
Y is, but what about with x? No, they're not. So this is what we're going to have to do. We have to find a common multiple between 3 and 2. Okay? So we can write values of 3 and values of 2. So what's 3 times 1 and 2 times 1 going to equal?
3.
22. Those aren't common multiples. What about times 2? 3 times 2 is?
6.
Yeah, 2 times 2 is? 4. Let's go times 3. 3 times 3 is?
9.
2 times 3 is?
6.
Yeah. Have we found any common multiples yet? No?
Well,
They both multiply to a specific number. Which number do they both multiply to?
6.
That's right. That is a common multiple. So, what that means is we need to turn both of them into the value of 6. In order to turn 3 into 6, we need to multiply by 2, which means that entire equation here, we have to multiply everything in it by 2. To turn 2 into 6, we had to multiply by,
3.
so this entire equation here, we have to multiply by 3. That way, our coefficients will be the same. Okay, so, let's rewrite them again. What's 3 times 2?
6.
Okay, so that's 6x. What's positive 1 times 2?
2.
Positive 2y. And what's 7 times 2?
14.
There you go. So we've rewritten the first equation. What's 2 times 3?
6.
So 6x.
Yeah.
What's negative 1 times 3?
Negative 3y.
And what's 3 times 3?
9.
There we go. Now are our coefficients the same?
Yes.
They are. Great. Now here's the tricky part again. We need to eliminate them. They're both what value? Positive 6. So do we add or do we subtract to get rid of both?
Subtract.
That's right. So we have to subtract both equations. So positive 6 subtract positive 6 gives us,
0x.
yeah, which cancels out. Now this becomes a little trickier. This is 2 minus negative 3. So you might want to put that into a calculator. 2 minus negative 3.
5.
That's right.
5y.
5y. Okay. And this is 14 subtract 9.
5.
We need to get y by itself. So what do we have to do?
Divide.
So what's 5 divided by 5?
1.
1. So our y value was 1 and our x value we discovered was 2. So the coordinate,
2, 1.
that's it, 2 and 1. And we've used elimination for both parts to solve this.